Hello and welcome to this live webinar focusing on mycotoxin control, brought to you by All About Feed, the leading magazine for all those involved or just interested in animal nutrition. My name is Jake Davis and I edit sister magazine Poultry World, and it's my pleasure to be here today to moderate the three speakers, all experts in their field, in this interactive session. We will hear from the speakers shortly, but for those watching live, please engage with the discussion by sending in your questions and comments via the chat box, which you should see at the bottom of your screen. We are broadcasting from Amsterdam, where just down the road, nutritionists from around the world have gathered at the 10th World Mycotoxin Forum to discuss this pervasive problem. While detection is improving and innovative solutions are helping control some of the health issues that can arise from mycotoxins, global climate change is increasing their prevalence in many regions. I looked up some figures ahead of today. Here in Europe, it is estimated that lost income for wheat alone as a result of mycotoxin contamination is between 1.2 and 2.4 billion euros. A huge sum, I'm sure you'll agree. We'll move on to our third speaker now, who is Brecht Bruneel. He's an international technical manager for feed additive business Orffa and plans to give a talk explaining the methodology that led to the development of the company's novel mycotoxin binding solution. And we're just setting up.
Yep.
You ready?
Yep. Thanks, Jake, for that kind introduction. So I would like to finalize this webinar with my presentation about looking into the mycotoxin binders. So we had the first presentation about the grain trading sector in Europe, with a lot of attention to sample variation and the necessity to make a good sample. We had a second talk about what are the effects or what are the mycotoxins that are relevant in poultry and also in swine. And now I would like to talk about solutions. So Orffa is very keen on providing solutions. And so the topic of today is looking into the mycotoxin binders and screening active components and benchmarking those commercial mycotoxin preparations. So if we look at the market situation, we see that a lot of producers provide a mycotoxin binder. If we then look to the different mycotoxin binders, we see that a lot of ingredients are being used in those mycotoxin binders. So the question of Orffa was, what is now the activity, the effectivity to bind the different mycotoxins inside the animal? Because we all know that we have a lot of mycotoxins, we have aflatoxins, fuminosins, I'm not going to name them all, but based on their chemical structure and also the interaction with other feeds inside the animal, it is difficult to bind them. So Orffa set up in vitro studies, so a lot of in vitro studies were set up to screen all thinkable ingredients, all thinkable compositions. We did this together with the University of Ghent in Belgium, with the laboratory of Professor Sarah de Saer, who has a lot of knowledge and is also involved in the MyTox program. For the people who do not know the MyTox program, I will explain it later in the next slide. So the setup of the in vitro studies was to look at different ingredients and what is the binding efficiency of the different ingredients in regarding the different mycotoxins. I must say that we tested a lot of ingredients, but also combinations of ingredients. So we looked for synergism to eventually come to a broad spectrum binder. And if we look at synergistic ingredients, we saw that if you, for example, have one ingredient that is very effective in binding zearalenone, you have one ingredient that is very effective in binding deoxynivalenol, you put them together in a mixture and you see the efficiency is going down. So you have to, in the end, look for a best synergistic mixture. So let's talk about the MyTox program. So we collaborated 7 years ago with the University of Ghent, looking at different ingredients, looking at different combinations of ingredients, together with the University of Ghent, with the laboratory of Professor Sarah de Saer. She is involved actively in the MyTox program. So for the people who do not know the MyTox program, it's actually a global initiative to solve the mycotoxin problems, not only looking at the mycotoxin problems in animals, but also looking at the whole picture. So they are also looking at mycotoxins in the field, where do they appear, which food and feed samples are contaminated. They look at the mycotoxin as such. They look at what is the effect on humans, what is the effect on animals. So a lot of in-house expertise, and we support this MyTox program. So in the end, we tested more than 50 ingredients, more than 50 combinations, and this is a small overview of what came out of that. So I would like to tell something more about this graph. To the left, we have in the blue column, we have the different mycotoxins. And you can see that, for example, if we look at DON at the top, you have DON at pH 3 and you have DON at pH 3 to 7. This is an important remark because when you look at the binding efficiency of a binder or an ingredient and you see that it binds effectively at pH 3, but it can lose its activity at pH 7. So we set it up this in vitro study, so we mimic the gastrointestinal tract from pH 3 to pH 7, and we're going to see it later in the benchmark study, that a lot of mycotoxin binders lose their activity at pH 7, and this is where, in the intestine, where the mycotoxins will have their damage. Just to explain something more about the legend we use, so you are not seeing binding efficiencies from 0 to 100, but we are using a legend. So to explain something more about the legend, if you see 3 pluses, for example, this is complete binding. This means that in the in vitro setup, the ingredient or the combination of ingredients is able to bind more than 90% of the mycotoxin. That's a very good thing. If we then have 2 pluses, this means that your ingredient binds the mycotoxin between 50 and 90%, so less binding. If you have 1 plus, this means that your mycotoxin is bound by the ingredient or the combination between 10 and 50%. And if you have a 0, that is binding efficiency below 10%. So this is actually a very nice legend to use, because otherwise, if you have a lot of ingredients, a lot of combinations, it is difficult to see which one is better in a general view. So, and then to make it a little bit more interactive, I've made this poll question. So let's start with the first poll question. Which mycotoxins are easy to bind with the stress to easy to bind in the gastrointestinal tract by current market mycotoxin management preparations? So we have all the mycotoxins there. Please make your choice. Jake, do we have something?
Yes, yeah, the poll's running, and we're just waiting for a few results to come through. Just still balancing out the bars, but yes, I think I'll draw it to a close because it's quite conclusive. Aflatoxins is by far the most popular, with 84% of people selecting that one. Second most popular was D, which you'll have to pronounce for me.
The second one?
D.
D, A, B, C, D.
Tricotocins. Yes, that's it, thank you. Yeah.
Yeah, it's a very difficult word and very difficult to bind as well. So if we look at the solutions, 84% of the people were right. Aflatoxins are indeed very simple to bind. And also the third one, or the C option, the eniatines, are also very easy to bind. Eniatines are really, I think, not many people have heard about eniatines, but they're appearing more and more. They're recently discovered in cereal and cereal-based products. And EFSA has looked at the toxicity, but they did not make a conclusion yet. So I think in the future we will hear a little bit more about the eniatines. So, and indeed, people were right. Aflatoxins, very simple to bind. Eniatines, very simple to bind. And then we have the yellow-colored mycotoxins, the fuminosins, the ochratoxins, the zearalenone, are more difficult to bind. And then we have the worst mycotoxins to have, are the trichoticins, very difficult to bind. And this will appear again in our benchmark study that I will talk about later. So in the end, we tested a lot of ingredients, a lot of combinations. We looked for the best synergistic mycotoxin binding mixture, and we came up with this product, Essential Toxin Plus. This is our broad spectrum binder, and of course we cannot claim that it is very efficient if we don't test it together with competitor products. So this is actually the benchmark study we set it up. We asked around in the world to our commercial colleagues, please find out, give us a sample of competitor products so we can see what is out there, what can be bound by those competitor products and what can be bound by our own broad spectrum binder. We are still testing more and more samples, so I think within a few years you will see a larger benchmark study appearing from Orffa. So this is actually the benchmark study. We have the same overview as the ingredients, the in vitro study with ingredients. So on the left we have the same. We have a binding efficiency at pH 3, we have a binding efficiency at pH 7, pH 7 more important. And then you see a lot of letters. The letters are presenting or representing the mycotoxin binders that we found in the market. The ones that are highlighted, darker colored, and have an asterisk, those are the top 6 premium products. So I will guide you through the slides. I've made some points. We have 1 until 5. Let's start with the first one. So if we look at the aflatoxins, easy to bind, everybody knows that, or 84% of the people watching knew that. And we see that back in our benchmark study. But what do we see? The first, if you look at the commercial product A, this is a top premium product, but we see that for aflatoxin G2, it has even a lower binding efficiency than the other premium products. So aflatoxin is very easy to bind, but some top premium products have some difficulties. If we then look at number 2, this is the zearalenone. For the zearalenone, in general, there is a lot of variation in the binding efficiency, and we see products that can bind very efficient at pH 3 and pH 7, but we see also a very low binding efficiency for some products. If we then look at number 3 is deoxynivalenol. Everybody knows DON, part of the trichoticins, very difficult to bind, and we see that back in our benchmark study. So all products tested, all commercial products tested, have low binding efficiency for DON. What also is important to note is that we can, from this result, we can also conclude that biotransformation of DON to less toxic metabolites is also minimal for these products, because when you test, you have your in vitro setup, you look at how much DON is bound by the commercial mycotoxin binders, so you analyze in effect the free DON inside the vial, inside the in vitro setup. So the free DON is analyzed via HPLC MS. So this also means that the DON is not transformed to less toxic metabolites in this setup. So we know that biotransformation is becoming a very popular term, but in this setup we don't see too much effect. If we then look at 4 and 5, 4 are the fuminosins and number 5 is the ochratoxins. And we see for the fuminosins and ochratoxins, we see a clear pH effect. And this is very interesting to see in our benchmark study. We have at pH 3 very high binding, and at pH 7 a lot of binders lose their binding efficiency to almost 0%. So this means that if your animal is eating fuminosins and ochratoxins, it does not want to eat it, but it gets it anyway, and it has a mycotoxin binder, one of those 19. It means that it perfectly binds the mycotoxin at pH 3, but it loses its effect at pH 7, where the mycotoxins will have their effect on the intestine. I also looked at other benchmark studies in literature, and I found these 3 papers, and these actually show the same conclusion, that zearalenone, difficult to bind. Some binders are very effective, others are not. If we look at the DON, very difficult to bind, not much binding of DON, and also low biotransformation. So, to make it again more interactive, let's have a second poll question. So what is, in your opinion, the most successful approach towards reduction of mycotoxic stress in animals? So we have the binding, we have the absorption, decontamination. The first one, the A, is the prevention, so mold control, storage management. Then we have number C, or letter C, we have deactivation, biotransformation, and we have D, letter D, we have detoxification and support, so supporting the animal by including feed additives that strengthen your intestinal barrier function and also support your liver. Jake, do you have an outcome?
Let's have a look. Yes, there's quite an overwhelming, and I'll just close the survey now. We have 74% choosing A, prevention, mold control, storage management. In joint second place, it's options B and D.
B and D.
Yeah, 10%.
Okay. Yeah. Okay, that's good to know. That's good to know for the future, that we have to stress on prevention, decontamination, and detoxification and support. A small conclusion is, from me, is that we have a lot of mycotoxin binders in the field. We see that all mycotoxin binder solutions have the same problems, and I think in the end we have to also look further than binding alone, because binding, absorption can be a first line of defense, but we have to look further to support and also mold control. Thank you.
Thank you. We have got one question which we have time to address quickly. How would you advise feed formulators approach their mycotoxin management?
Yeah, thanks, Jake. Regarding feed formulators, I would advise, as I already concluded, that absorption or binding can be the first line of defense. We see from our benchmark study that we have a lot of mycotoxins like the DON, the trichotillins, that are very, very difficult to bind. And we have companies that already invested a lot of money in searching for binders, but in the end we see very low binding. So we should also switch to other measurements and not only think of mycotoxin binders, but also think of whole mycotoxin management solutions. And this is by providing also hepatoprotection and support to the epithelial cell layer. Thank you for watching, and goodbye.